This week's topic is how energy moves. We're going to watch a video called The Cat Came Back, which is a reminder of the law of conservation of matter and energy, which states that matter can neither be created nor destroyed, it can only change forms, and the same is true for energy. Energy can change from mechanical motion into heat energy. It can change from electromagnetic energy into light and heat energy. But it can neither be created nor destroyed. It's just changing form. But one of the things that remains to be answered is, what is energy exactly? Richard Feynman once stated that it is important to realize that in physics today we have no knowledge of exactly what energy is. We can define energy as the ability to change the motion of matter, either speeding it up or slowing it down. And we know that there are three kinds of energy. There's gravity, which is based on an object's mass, electromagnetism, which is based on an object's charge, and then we know that it travels in waves. And then there's nuclear energy, which holds atoms together. This week we're going to focus in on electromagnetic energy. Electromagnetic energy travels in waves. These are the parts of a wave. The crest is the top and the trough is the bottom. A wavelength is the distance between one crest and another. The electromagnetic spectrum lists all of the waves in order from shortest to longest. We have on the infrared, that's basically heat energy. In the visible spectrum, that's where we have sunlight. The ultraviolet is this part of the spectrum where insects often see the world. We have radio waves, which is where cell phone calls and radio stations transmit. And then there are X-rays and microwaves. This is all things that we're familiar with. But in earth science, we're going to deal with the part of the spectrum that deals with sunlight and heat energy. There are three basic methods of transferring electromagnetic energy. The first is convection, which is transfer of heat energy caused by differences in density of a fluid, and we talked a little bit about that in last week's video. Conduction is the transfer of heat through a direct contact, and radiation is the transfer of energy waves through empty space. We're going to explore each of these in more detail. With convection, we have a heat source underneath this pot of water, and we can see that when the water is heated up, it becomes less dense, and therefore it starts to rise. As it moves away from that heat source, it starts to cool down and become more dense, and then it starts to sink, and it creates this circular motion in the pot, and that is convection. Conduction is when heat is moving through a solid object, and here we have heat moving through a solid metal rod, transferring energy from the hot water container to the cold water container. It's important to note that heat always moves from the hot thing to the cold thing, and this is often said that it moves from source to sink. Some materials are better at conducting energy than others. Good conductors include solids, rocks, especially metals, and high-density substances. Bad conductors are liquids and gases, wood and plastic, and low-density substances. Radiation is when electromagnetic energy is transferred from its source through empty space, and that's why we can see light from distant stars. They don't have to have a medium to travel through. Radiation can also go through solids, liquids, and gases, but it loses energy. As the density of the medium increases, less radiation can pass through. And we can see if you hold your hands close to a fire, there's not a lot of air for the energy to pass through, so you can feel the warmth. But if you're far away from the heat source, there's a lot more air, and in this case there's actually a solid object that is blocking the heat, and so you don't feel the heat traveling through. We're going to focus a lot more on radiation next week. The last thing we're going to talk about this week is specific heat. Specific heat capacity is the resistance a material presents to heating up or cooling off. The higher the specific heat capacity, the greater the material's resistance to changing temperature. On page 1 of your reference table, it lists in order from the highest specific heat value to the lowest, and we can think of the materials that have the highest specific heat as being very stubborn and resisting change, and the ones that have a low specific heat value to being very easygoing and changing very easily. A substance like iron has a low specific heat capacity, and it changes temperature very easily. A substance like water has a very high specific heat capacity, and it takes a lot of energy to get it to change temperature.